Good day, grade 12s. My name is Goodness Shoba. Our today's topic will be factor and remainder theorem, which will assist us in factorizing the cubic functions under the calculus section, right? So I would like us to go through the lesson outcomes together. Our first lesson outcome here is to ensure that every one of us here is able to apply the remainder and the factor theorems to polynomials of degree at most 3. And then the second one is to ensure that you are able to do what? To factorize the third degree polynomials by using any method which requires the factor theorem. What is this polynomial that we are talking about here? This polynomial refers to an expression in x of the form ax to the power n plus bx to the power n minus 1 plus, there are missing terms in there, then plus jx plus up to the last term constant k. Remember, this k is our constant, where a, b, c up to the constant k are what? Represent real numbers, and a is not equal to 0, and n is also a positive integer. Remember, if you say our a is equal to 0, look at what this is going to happen here. If you say your a is 0, it means now you're going to get what? You are no longer going to get a polynomial expression, but you're going to get a whole number, of which that one is not part of what? Of our polynomial. Remember, I can also, going back to the previous slide, I can also add under this polynomial to say, from our grade 10, just to give you a revision, just to recap on this, from our grade 10 content, we have learned about the linear polynomial ax plus b. How do you see that this is a linear polynomial? The highest power is 1. So in grade 11, you dealt with both linear and quadratic. So in grade 11, you dealt with both linear together with the quadratic, ax squared plus bx plus c. This is the format of what? Of our polynomial in grade 11. So now in grade 12, we will be adding to what we are having already. Our linear and our quadratic, we will be doing what? The cubic polynomial, which is of the form ax cubed plus bx squared plus cx plus d. So our main focus will be here in grade 12. We will be dealing with this. We will be working with the factorizing of these cubic polynomials, right? Now, a remainder theorem. We say a remainder theorem is an algebraic theorem which states that if we have a polynomial f at x is divided by what? By a linear polynomial x minus b, then the remainder of this will be what? Will be f at b. So in short, this can be abbreviated to f at b is equal to r for what? For our remainder. So this dividing rule here holds for all the x values under this polynomial theorem, this remainder theorem. So what does this f at x stands for? This f at x is meant for our dividend. We call this f at x our dividend, and then this x minus b, our divisor, and then this q at x is our quotient, and then this r is for our what? Is for our remainder. So in simple terms, we say dividend is given by what? Dividend must be equal to what? Your divisor multiplied by your quotient plus the remainder. Okay. Now, let's go to example number 1. Example number 1, here we are required to do what? We need to use the remainder theorem to determine the remainder when our given function f at x is equal to 4x cubed minus 8x squared plus x plus 2, when it is divided by what? Let's start with letter A. When it is divided by x minus 1. Okay. Here, I'm going to write my solution. Number 1A. Remember, we said with the remainder theorem, our f at b must be equal to what? Must be equal to what? R for what? For remainder. For us to get the remainder theorem, we need to go the root of f at b is equal to. So in this case, where do I get this f at b? How do I determine that f at b? Or how do I determine this b? It's quite easy. I'm just going to make use of my divisor. So you take your divisor as what? X minus 1, and you equate it to what? To 0, and solve for x. We're going to have x is equal to positive 1. So in place of this b, I'm going to have my positive 1 there. So I'll be saying f at 1, remember you substitute this into your original function there, or your original polynomial. F at 1 is equal to 4 into 1 all to the power 3, there it's all to the power 3, minus 8 into 1 all squared, plus, brackets are very much important, open bracket, 1, close bracket, plus 2. So 4 multiplied by 1, we say it's 4 because 1 cubed is 1, minus 8 multiplied by 1 there, 1 squared is 1, so it's 8, 4 minus 8, plus 1, plus 2. So 4, if I can add this together, 4 plus 1 plus 3 is going to be 7, minus that is going to be negative 1. So in simple terms, my f at 1 will give me what? Will give me the remainder of negative 1. Okay? Let's move to the next one, letter B. This one is more or less the same as that one, but now the only difference is that our b, or our value of b, will no longer be the same as the previous one. So still, we need to equate our divisor to 0 in order for us to obtain the value of what? Of b there. So 2x minus 1 is equal to 0. So 2x will be positive 1 transpose, divide both sides by 2. So your x is going to be 1 over 2. Now, what do I do with this 1 over 2? So I need to make sure that I substitute this 1 over 2 into the given function there, so that I can get what? My remainder. So my f at 1 over 2 is equal to 4 into 1 over 2 all to the power 3 minus 8 all to the power 1 over 2 all to the power 2, remember, plus, brackets are very much important, plus half again, plus 2. Now, let's just simplify this. You can punch this in your calculator, or you can just calculate by inspection. 4 multiplied by that, you can see 4 multiplied by 1 over 8 is going to be 1 over 2 minus 8 multiplied by 1 over 4. It's minus 2 plus half plus what? Plus 2. So as you can see here, if I can just say 2 minus 2 is going to be 0. Then half plus half will give me, let's continue to this other side. Our answer is going to be half plus half. It's going to be positive 1. So in this case, if my f at x is divided by 2x minus 1, I'm going to get the remainder of positive 1. Okay. Now let's move to this other theorem, which is what is called the factor theorem. You cannot say this one is the same as the remainder theorem, remember. With this factor theorem, we can use it to apply, or it can be generally applied to factorizing and finding the roots of polynomial equations. So in simple terms, we can use this factor theorem. We are going to use this factor theorem to factorize and find the roots or the x-intercepts of our polynomial equations. According to this theorem, it states that if f at x is a polynomial such that f at b is equal to 0, then our x plus b is going to be what? It's going to be a factor of the polynomial, right? So in reverse form, or conversely, we can say if our x at x plus b is a factor of the given polynomial, then it means now our f at b is 0, or our remainder of this is going to be what? It's going to be 0. Okay. In this case now, let's just look at the difference between the factor and the remainder theorem. So with the factor theorem, our remainder is strictly 0, whereas with the remainder theorem, our remainder can be any value, but the value will not be equal to what? It will not be equal to 0. Otherwise, it will lead to the factor theorem. Now, with this example 2, or in example 2, we are required to show that x minus 3 is a factor of the polynomial. How will you see that x minus 3 is a factor of this polynomial? So in this case, for us to see that this is our factor of the polynomial, let me present my answer here. For us to see that this is a factor of the polynomial, our f at b, or our remainder, should be equal to what? Should be equal to 0. Okay? Where do I get this b? How do I determine b? Straightforward. You just go to your divisor, take your divisor, and equate it to what? To 0. Therefore, your x is equal to 3. In place of b, now I have what? I have 3. So in other words, I'm looking for what? My f at 3 must be equal to what? Must be equal to 0. Now, I'm just going to substitute my 3 into the original function. So I'll say 3 all to the power 3 minus 3 all squared minus 5 into 3 minus 3. So 3 cubed is 27 minus 3 squared is 9 minus 5 times 3 is 15. And then you're going to have minus 3. Then when you simplify this whole thing, 27 minus 9 minus 15 plus that gives you 0. Therefore, if your remainder is 0, then it means you can say my x minus 3 will be a factor of the polynomial. So now you have shown that this x minus 3 is indeed a factor of the polynomial. Then you are covered with this one, right? Remember, the remainder should be equal to 0 for you to say this linear is a factor of my given polynomial function. Okay? Now, moving on to the next slide. Here, I was trying to emphasize to you the methods or the ways in which a cubic polynomial can be factorized. So for you to factorize a cubic polynomial, you need to ensure that, number one, you apply the knowledge of your factor theorem by using what? By ensuring that you get at least one factor using that. How do you determine that? Make sure that you focus on the constant of your given function. From there, you can just use your trial and error method to determine the exact factor of the polynomial. From there, you can just use any method from the list. You can use your long division, you can use your synthetic, or you can use your inspection method. Now I'm going to take you step by step on how to treat or on how to deal with each and every method here. Right? Let's do example number 3A together. Here we are required to factorize these polynomials or functions by using the long division method. How do we use the long division method? If you can just make sure that you have this portion. This is for my rough work, guys. This is for my rough work. That's where I'm going to write my proper work here. Right? It should be presentable. Now, let's look at the first equation. Our first equation in A, we need to find, number one, remember we said we need to find all the possible factors of our constant term. In this case, what is our constant term here? Which one is our constant term? Our constant term is plus 6 or positive 6. So what are the factors of this positive 6? Remember, a factor from our grade 9, we know that a factor is a number that can divide exactly into another number without leaving any remainder. So in here, a number that can divide into plus 6 is positive, plus or minus 1. We have plus or minus 2. We have plus or minus 3 can divide into this. And then you also have a plus or minus 6. Then what do I do with these factors? Simple. I'm going to use the trial and error method. This is how I'm going to use my trial and error method to test as to whether which one gives me the remainder of 0. And then when you get the remainder of 0, it means that particular value will serve as your factor of the polynomial. Now, let's try this one, the positive one. F at 1 is equal to 1 cubed minus 4 into 1 squared plus 1, brackets are very important, plus 6. Therefore, what is your F at 1? You're going to have 1 minus 1 cubed is 1, minus 4, plus 6, or plus 1, plus 6. Then when you simplify this, you're going to get what? Negative 4 plus 2 is negative 2 plus 6 is going to be positive 4. What does that imply? This simply means that our x, look at the sign there. Our sign here is positive, so it means our x minus 1 is not a factor of the polynomial. Why? Because our remainder is 4, not 0. So what do we do next? We need to try the next factor. If we failed with 1, now we need to try with negative 1. So how do you do that? Simple. You substitute your x now with negative 1. Just say negative f at negative 1 is equal to negative 1 cubed minus 4 into negative 1 squared. Then continue from this to this side. I don't have enough space. And then we can have negative 1 plus negative 1, right? From your original. Make sure that you substitute correctly. And then we have plus 6. Therefore, what is your f at negative 1? It's 1, negative 1 cubed. It's going to be negative 1 minus 4 times 1 minus 4 minus 1 plus 6. Therefore, what is your f at negative 1? Your f at negative 1 is giving you what? 0. Minus 1, minus 1, minus 1 is giving you 0. Then you can stop right there. Because now your remainder is 0, you can conclude to say, okay, therefore, to the next slide or to the next portion here, you can say, therefore, f at negative 1, since it's equal to 0, it means now x, remember, if it's negative here, your factor should be positive. So x plus 1 is a factor of the polynomial. This is what matters for now. Remember, we said we need to use our factor theorem to get at least one factor. Now we are covered with the first factor now. From here, we need to use our method, the long division method. Let me take you back to our your grade 9 content. Remember, in grade 9, they will say to you, divide this number, 97 divided by maybe, they will say divide by 3, using your long division method. And then you'll say, your long division sign, remember, this portion is meant for what? You must know that this part is for your dividend. And then this one is for your divisor. And then here it's meant for what? For the quotient. And then our answer at the end, the answer that you're going to get at the end there is the remainder, right? So with your grade 9 content, which one is your dividend here? Your dividend is going to be 97. And then the number that is divided by is positive what? 3. So your 3 is going to be your divisor. So it's your divisor 3. You're simply going to say 3 into 9 goes how many times? It goes how many times? 3 times. There, you write your 3 there. 3 multiplied by 3 is going to be 9. Then what do? You subtract. 9 minus 9 is going to be 0. Even if you don't write it, it won't make any difference. And then you bring down the next term. Sorry, you bring down the next term there. 97. Your next term is, it's 7. Then you can bring down your 7 there. It's 7. 3 into 7 goes how many times? 2 times. So 2 multiplied by 3 is going to be 6. You write it underneath this 6. 107 is going to be 6. Then you subtract the two terms together. 7 minus 6 is positive 1. So this positive 1 is your remainder. Now we are going to apply the same method, but now using the polynomials. This is quite easy. Using our polynomials. Remember your long division sign? Which one is your dividend here? Your dividend is going to be the given function there, x cubed minus, remember this is your dividend, right? So x cubed minus 4x squared plus x plus 6. Then which one is your divisor? Your divisor is the factor now. Your factor is x plus 1. So you're going to have your x plus 1 here. Now, you simply say the same procedure. X into x cubed goes how many times? Is x squared. So remember, you need to align your terms. It's x squared. X squared multiplied by x is x cubed. What do you do again? X squared again multiplied by positive 1 is positive x squared. Remember to align your terms. And then you subtract the terms. Now you subtract. When you subtract, x cubed minus x cubed is 0. Minus 4x squared minus x squared is negative 5x squared. Guys, remember to align your terms together. And then you bring down the next term, which is positive x. What do? You start the process again. To say x into minus 5x goes how many times? Negative 5. 5 multiplied by x, negative 5. It's negative what? Negative 5x, sorry. Negative 5x squared. Negative 5x squared, or negative 5x multiplied by 1 is going to be negative 5x. What do? We subtract the terms together. Minus 5x squared minus negative 5x squared is 0. X minus negative 5x is going to be positive 6x. Remember, it's x minus negative 5x. So when you multiply, this is going to be positive, right? So it's 6x. Then what do? You bring down the next term, which is positive 6. From there, you need to start the process again. The process again will be to say x again into 6x goes how many times? It's plus 6, positive 6. 6 multiplied by x is positive 6x. 6 multiplied by 1 is positive 6. What do? We subtract again. So 6 minus that is 0. That minus that is 0. Therefore, your remainder is 0. Remember here, we were required to do what? To factorize. Let's utilize this portion. You are required to factorize this. Therefore, remember, our dividing rule says our dividend is given by what? Is given by the divisor multiplied by the quotient plus the remainder, right? So our dividend, in this case, let me just make use of this D, capital letter D for dividend, and then small letter d for our divisor. So dividend is equal to divisor multiplied by q for quotient, and then plus r for remainder to save space here. I don't have enough space. In this regard, which one is my dividend? My dividend is going to be f at x, the original function there. F at x is equal to, which one is my divisor? X plus 1. My quotient, this one is your quotient here. There is your quotient. Your quotient is x squared minus 5x plus 6, right? Minus 5x plus 6. Therefore, what is your final answer on this one? You're going to have your factors as x plus 1, and then you can factorize this. Remember, this one is your quadratic expression. You are able to factorize it. So the factors of this will be x and x, And then the sign here is positive, so the sign is going to be positive and positive, or negative and negative. In this case, I'm going to make use of the negative and negative, because now the middle sign is negative, so it's negative. I'll consider minus and minus. So the factors of 6, we have 6 and 1, right? 6 and 1, positive 6 and 1. We also have 3 and 2. So in this case, I'll make use of what? I'll utilize 3 and 2. So it's 3 and 2. Remember, when you multiply this x together with this negative 2, it's going to be 2x. Together with this one, negative 3x, they must give you what? The sum of these two must give you the middle term, which is negative 5x. So our factors are indeed correct. And now we are done with this letter A. Let's move to the next one. Moving to the next one. My rough work there. Guys, you can always use your calculator. Feel free to use your calculator. Now, your f at x is equal to x cubed minus 12x plus 16. Remember, we said we need to find all the possible factors of what? Of 16. We have plus or minus 1. Let me write them here. Possible factors of 16. We have plus or minus 1, plus minus 2, plus minus 4, up to, or plus minus 8. You can also write plus minus 16. Those are the possible factors of what? Of 16. But in this case, if you can look at this function or this polynomial, other terms are missing. Remember, we are saying this cubic polynomial should be in the form of what? Ax cubed plus bx squared plus cx plus d, right? But in this case, there is this other term which is missing here. The second term plus bx squared is not here. What do I do? In this case, you need to make sure that you add the missing terms to this polynomial. So it's x cubed, but you must ensure that the coefficient of that missing polynomial is what? It's 0. So it's x cubed plus 0x squared minus 12x plus 16, right? Now you need to find your f at 1 using the first factor. They use your trial and error method. F at 1, we have 1 all to the power 3. Then 0 multiplied by x squared, it will just give us 0. I'll just write plus 0 minus 12 into 1 plus 16. So I'll have 1 minus 12 plus 16. So when you simplify this all together, it's going to give you negative that. Then it's going to be 4 plus 1. It's going to be 5. So now your remainder is 5. It means x, look at the sign. If it's positive, you say x minus 1 is not a factor. Remember, you can use your calculator to check all the other factors there. You can also test the other factors. F at negative 1. Let's make use of the calculator to save time. Your f at negative 1, you're going to substitute with your negative 1 there. Negative 1 cubed. Avoid making mistakes, please. Minus 12 into negative 1 plus 16. So your answer is positive 27. It means still x plus 1 is not a factor. Correct. Now, let's just change back to your calculator. You just change the number, negative 1, and utilize positive 2 now. You punch in positive 2. When you punch in a positive 2, you get the remainder of 0. Then you can just say f at positive 2 gives me 0. Therefore, it means x, look at the sign positive, I'll say x minus 2 is a factor of the polynomial. So what do? I'm done with the factor theorem. Now I must apply the method now. Any method that I can use here. my long division method. You write in the given function as it is. Remember the missing terms. You need to include in the missing terms. So x cubed plus 0x squared minus 12x plus 16. Don't forget your divisor. Your divisor is now x minus 2. Remember the division method, the long division method is quite easy. The procedure is still the same. You divide, you multiply, you subtract, and then you bring down the next term, just like that. So x into x cubed, align your terms. It's x squared. X squared multiplied by x is going to be x cubed. You see? You divide. Now you're going to multiply after this. X squared multiplied by negative 2 minus 2x. Can you see? You divide, you multiply, you subtract, you bring down the next term. So now you're going to have negative. You subtract the terms. X cubed minus x cubed. X cubed minus x cubed is going to be 0. 0x squared minus, sorry, this is 2x squared. 0x squared minus negative 2x squared. This is going to be what? Positive 2x squared. Then what do? You bring down the next term, which is minus 12x. Then you start the process again. X into 2x squared goes how many times? It's positive 2x. 2x multiplied by x is going to be 2x squared. 2x multiplied by negative 2x, negative 4x. It's going to be negative 4x. Then what do? You subtract the terms. 2x squared minus 2x squared is 0. Then 12x, remember it's negative. 12x minus negative 4x is going to be negative 12x plus 4x. So it's going to be negative 12 minus 4, going to be negative 8x. Then we bring down the next term, which is positive 16. Right? X into negative 8x goes how many times? So it's minus 8. 8 multiplied by x, or negative 8 multiplied by x is negative 8x. Minus 8 multiplied by negative 2 is going to be positive 16. Then you subtract your terms together. Minus 8x minus into negative 8x is going to be 0. 16 minus 16 is 0. Therefore, your remainder is 0. If your remainder is 0 like that, it means you can apply. You can always apply your dividing rule to say now the dividend is equal to the divisor multiplied by the quotient plus the remainder. In this case, our remainder is 0, so that won't make any difference. So our dividend is f at x is equal to, our divisor is x minus 2 multiplied by the quotient. Sorry, the quotient is x. Let me write it here. F at x is equal to x minus 2 multiplied by x squared plus 2x minus 8. Therefore, what will be the factors of the trinomial? You can use the quadratic formula, you can use the trinomial factorization, that's up to you. So we have x and x, we have minus, I'm looking at the sign, the negative sign there, it's going to be minus and plus, minus and positive. So the factors of 8, you have 8 and 1, we have also 4 and 2. So now I'm going to make use of this 4 and 2 part. Remember now, the bigger factor will take the sign of the middle term. In this case, the bigger factor is 4, so it's going to take the sign of the positive sign there. Since the middle term is positive 2, so it's minus then you say minus 2. Those are the factors. But in short, you can just sum this to be x minus 2. You can write it as x minus 2 all squared multiplied by x plus 4. All right. That's all about our long division method. That's how we factorize using the long division method, okay? So now I need us to try the next method. I would like us to try the next method, which is the synthetic division method. Let's see then at the end so that we can compare. So that you can choose which method are we comfortable with at the end. Now let's go through the second or the fourth example. In our fourth example, we are required to factorize this still, but now we need to strictly use the synthetic division method. The first question there, you are given f at x is equal to negative x cubed plus 7x squared minus 15x plus 9. What did I say? I remember I said you need to start by determining or finding all the factors of the constant. In this case, our constant is positive 9. So positive 9 is going to be plus or minus 1, plus or minus 3. We have plus or minus 9. Those are the factors of what? Of our constant 9. Then what do we do from here? You use your trial and error method. Even if you don't write all your workings there, you just need to find the remainder of 0. When you get the remainder of 0, it means that particular value will serve as your factor. So now let's substitute. Our first factor there, let's substitute with negative, positive 1. No, in this case, let's start with positive 1. Positive 1 cubed. To save time, positive 1 cubed plus 7 into positive 1 squared minus 15 into positive 1 plus 9. Then here, our f at 1 gives us the remainder of 0. Therefore, we can say it means x minus 1 is a factor of the polynomial. Okay, remember guys, we are using the synthetic division method. So how do we use this method now? You're just going to draw the sign. Looking at your factor now, your factor is x minus 1. Now you need to make sure that you do what? You write the reverse of this one, the inverse of the negative sign, which is going to be what? Or you can just say, let's switch the sign from negative to be positive. Now you need to write down all the coefficients of your given function here, starting from the coefficient of a. In this case, the coefficient of a is negative 1. Write it down. The coefficient of b is 7, and then we have minus 15. Then the last one is plus 9. Now, remember I said here is positive 1. You need to bring down the first value, or your first coefficient. The value of your coefficient is negative 1. So positive 1 here multiplied by negative 1. So it simply means you're going to get what? Negative 1. You write it underneath the next value. Then what do we do? 7 plus negative 1 is going to be positive 6. And then positive 1 multiplied by this 6 is going to be what? Positive 6. Negative 15 plus positive 6, that is going to give us what? 9. Negative 9. Negative 9, correct? Then you say positive 1 again multiplied by negative 1. That is going to be negative 9. So you say 9 plus negative 9 is 0. So this 0 serves as what? As your remainder. Remember, this is a synthetic division method. So in this case, you can apply your dividing rule to say dividend, d for dividend is equals to small letter d for divisor multiplied by the quotient plus the remainder. In this regard, which one is our dividend? Our dividend is the given function f at x. So f at x is equal to our divisor. Here is our divisor, the factor, the x minus 1. Now, remember, when you multiply a linear together with a quadratic polynomial, you get a cubic. So this quotient is in the form of a cubic. It's in a quadratic form. It's ax squared plus bx plus c. So one maybe is wondering, where do we get this a, b, and c? So this is quite easy. A is the coefficient. -1 is our coefficient of a. This 6 represents our b. Then this -9 is our c. Then you're just going to substitute this into this quadratic expression, -1 into, then you say -1 multiplied by x. Remember, I said this -1 is the coefficient of what? Of this x squared. So -1 times that is -x squared plus 6x minus 9. Remember, we can always take out the common factor from our next bracket. We can always take out the common factor of negative, just say multiplied by negative sign into negative times that one is x squared minus -6x divided by that is minus 6x, and then it's going to be plus 9. Okay. Then this can be simplified too. This can be simplified too. Remember, you can also multiply this negative this side. Negative into x minus 1. Now let's just determine the factors of the trinomial. So we have x and x. I'm looking at the sign there. The sign of the constant is positive, so it's positive. You can use positive or negative only, but I'm looking at the middle sign. The middle sign there is negative, so it means now we're going to consider minus and minus. So -3 together with -3. Okay, I hope everyone is fine with that one. Therefore, our last term or our last solution there will be equals to negative into x minus 1 multiplied by x minus 3 all to the power 2. Those are the factors of the polynomial by using the synthetic division. Okay, I hope everyone is fine with that one. Let's try the next one. The second one here. But still, let's use the synthetic division so that we familiarize ourselves with these different methods. And then at the end, you can choose any method of your choice, remember. You are not restricted to choose long division or synthetic whenever you feel like using the other method, either way around. Okay? 2a. Now you are given this function. Remember, I said if you are given a function like this one, where there are missing terms, you need to make sure that you add in the missing terms. So g at x is equal to, still, we don't have all the terms here. So it's x cubed. You don't have the term x squared. So we need to say plus 0x squared. You need to ensure that the coefficient of the missing term is 0. So minus 12x plus 16. Remember, from our previous slide, we already know the factors of what? Of plus 16. So remember, it's plus minus 1. I'm not going to write them again. I'm just going to write the few. Plus minus 1, plus minus 2, up to plus or minus 16. You need to make use of your calculator, guys, to save time. You don't have to write the whole statement here. So it's 1. Oh, by the way, we did this one previously. So we already know that our f at 2, let's try it again. 12 into 2 plus 16. Oh, since we know that in this case, we don't have g, but you are given I mean, you don't have f at x, you are given g at x. So our g at 2 gives us the remainder of what? Of 0. Therefore, it means x minus 2 is a factor of the polynomial. Since x minus 2 is a factor, going back to your synthetic division, remember to switch the sign of your factor is minus 2, so you need to write positive 2 right here. And then you need to write down the coefficients of the function. The first coefficient here is 1, then you have 0, then you also have to write negative 12, you need to also write positive 16. What do we do next? You bring down the first value there. So the first value is positive 1. Then what do we do? 1 multiplied by 2, positive 2. 0 plus 2, positive 2. Right? 2 multiplied by 2 is positive 4. Minus 12 plus 4 is going to be negative 8. 2 multiplied by negative 8 is going to be negative 16. Then what do we do? 16 plus negative 16 is 0. So since this 0 is your remainder, you must know that this 1 is the coefficient of A, 2 is the coefficient of B, and then this negative 8 is the coefficient of C on your quadratic expression. Right? Remember, in this case, dividend is equal to divisor multiplied by quotient plus the remainder. Our dividend is g at x is equal to x minus 2 is our divisor. This factor is our divisor. And then, remember, this is in the form of ax squared plus bx plus c. But there's no need to write this in the near future. And I'm just showing you the example. So x minus 2, the coefficient of a here is 1. So it's 1 multiplied by x squared is x squared plus 2x minus 8. Correct? Now you can determine the factors of this trinomial. You can use your trinomial factorization. You can use your long division method. We have x, and then the factors of minus, this minus sign is going to be negative and positive, right? So now we can have what? Negative and positive from there. Minus positive, that one is 8 and 1. We have 4 and 2, right? So the sign, remember the bigger value, take the sign of the middle term. So it's going to be 4 and minus 2. Therefore, we're going to have x minus 2 all squared together with x plus 4. Remember, now they are saying, moving to the next question, hence, show that g at x is equal to 0 will have how many roots? It will have 2 roots. Now, let's make it fast. We don't have time anymore. From here, remember, when they say hence, they want to say using what we have already worked out, you need to determine the values of what? 2 roots, the solutions of x. So you just say, since my g at x is equal to what? 0. Remember, this is what? Is 2, letter B. Since my g at x is equal to 0, I will have to say x minus 2. I don't have to start afresh to do the calculations because it's already there. X minus 2 and x minus 2 multiplied by x plus 4 is equal to 0. Correct? Therefore, we can have our x is equal to 2 or our x is equal to negative 4. Therefore, it means our g at x has 2 solutions indeed. All right. Okay. Because we don't have time anymore now, let's move quickly to the last example there. But now I'm going to use the other method, inspection method. Let me be fast on this one. The inspection method, example number 5, the inspection method. You are required to factorize the following polynomials by using the inspection method. So by this inspection now, I don't have to copy down this question. It's already there. You already know the factors of plus 6 is plus or minus 1. If you can just utilize this 1, substitute your factors there, 1 cubed minus 4 into 1 squared plus 1 plus 6. So you change to minus 1, minus 1, minus 1. So it means now in this case, our f at minus 1 is 0. Therefore, it means x plus 1 is a factor of the polynomial. Ax squared plus bx plus c is a factor of the polynomial. Now, let's look at this. You need to determine the coefficients of a and c by inspection. So now remember, when you multiply this x multiplied by ax squared, it will give you this term here, x cubed. So now you can know the coefficient of this x here is 1. So 1 multiplied by any number should give you this coefficient of x cubed. So 1 multiplied by 1, it will be positive 1 here. So here I have ax squared plus bx and then plus c is the constant. When I multiply this positive 1 together with c, I must be able to get which one? To get this positive 6 here, right? So 1 multiplied by positive 6 is going to be what? 1 multiplied by positive 6 is going to be what? 6, the constant of the original, right? Remember, f at x is equal to. Now, the factors will be, how do I determine this coefficient of b now? I need to say, or consider the values or the products that will give you a term with an x squared. The first one is going to be x multiplied by this. When you multiply x together with that, it's going to be bx squared. Then 1 multiplied by x squared is plus x squared. Then you equate it to the like term from the original function. They are equal to negative 4x squared. Now, common factor is x squared into b plus 1 is equal to 4x squared. Now, you just equate the bases. b plus 1 is equal to 4. Negative 4, sorry. b plus 1 is equal to negative 4. Let's write negative 4 here. Therefore, b will be negative 5. Then, in conclusion, I'll say x squared minus 5x plus 6. Therefore, you can just factorize from there. X plus 1, x and x. Then the factors there will be minus and minus 3 and 2. Those are the factors of the polynomial f at x is equal to that. Guys, I think we have reached the end of our lesson. Remember, practice makes perfect. Until we meet again next time, guys, goodbye for now.